So welcome to the third lecture of Corporate Finance for MSc Finance. So today we're going to talk about asymmetric information. So asymmetric information essentially is so the part that we are focusing on, which is adverse selection, essentially is hidden information. So the entrepreneur might have information that the investors do not have about the project or about actually his own abilities. So remember, for the context, we're looking at this principal agent setting in which there is this investor who's going to write the contract with the entrepreneur, and the contract is dealing with how to divide up the benefits of the project that this entrepreneur can carry out. And of course, these investors want their money back. So these investors are the principals, the entrepreneur is the agent. And so far, the last 2 weeks, basically, we looked at a form of asymmetric information which is called moral hazard, or in other words, hidden action. So that meant the investor has no perfect knowledge about what the entrepreneur does. So particularly we looked at the case in which the entrepreneur does or does not choose effort, and if the entrepreneur does not choose effort, then we had these private benefits, you remember. So there is some incentive for the entrepreneur to actually not behave according to the interests of the investor, and we have to do something in terms of designing the contract in such a way that these incentives are again aligned between these two parts to the contract, these two parties to the contract. So today we, as I just mentioned, we are going to look at the other form of asymmetric information, which is adverse selection. So adverse selection is goes by a different name of hidden information. So hidden information means there is something that, well, in principle we cannot do anything about, but the entrepreneur knows whether information is good or bad, or so, for instance, whether the project is a good or a bad project, but the investor does not. So the investor only perhaps has some prior. So they might know, well, with some probability this project is good, but it might actually also be a bad project. And based on that prior, the investor has to decide, am I willing to put my money into this project? So basically the analysis, the economic analysis of information asymmetry of this kind of hidden information goes back to a famous paper by George Akerlof in 1970 actually. Essentially what he later got the Nobel Prize for. And this paper is called The Market for Lemons. Lemons is an American slang term for used cars, and particularly used cars which are not very good. And so his paper was about a used car market indeed. So here's an example, a current example actually on eBay for used cars. And you can imagine that, on the used car markets, you will find lots of different kinds of cars, and some will be better than others. So if you're a seller, you might have a very poor car, which you put on the market, but obviously you're not going to tell everybody it's a very bad quality car. Or you might have a very good car, and you might want to also sell this car because you want a new one, and so you will also be putting this new car or this good quality used car on the market. Now you as a seller, you know the quality of your car, but if you're a buyer, you might have a hard time telling the good ones apart from the bad ones. So the point here that Akerlof made was, well, suppose we look at this from the point of a buyer. You want to buy such a car in the used car market. Well, essentially, you do not know, is it a good car or a bad car? So it might be either. So what am I willing to pay for this? Well, not too much, because I might buy a lemon, right? I might buy a bad quality car. So I'm going to sort of just assume on average, I'm going to buy an average quality car. So that's what I'm willing to pay for this, right? So I'm going to pay sort of an average price. I'm willing to pay an average price for the average quality car on this market. Now put yourself in the position of a seller. Suppose you have a very good car. Are you going to put this car on this market knowing that you will only get a price for this car which accords to an average quality car? Well, probably not every good car owner will be willing to participate in this market. They don't want to sell their great car high quality car on this market for an average quality price. So some of the good quality car sellers will actually not participate on this market. But let's go back to the buyers. They know that the best quality cars will not actually appear on this market because prices will be too low. So you actually downgrade your prior for what the average quality on this market might be, and you're actually willing to pay even a bit less than that because the best cars are actually not on this market. Only slightly poorer cars are on this market. That's going to drive down prices. But then again, you will some of the sellers of them, well, slightly less high quality but intermediate quality cars might not participate on this market either. And you can see where this goes. The quality on this market will, in equilibrium, deteriorate until only the very lowest quality cars will remain on this market, provided that actually there is any demand for these very lowest quality cars. So this market might even stop to exist. So this insight is again due to Akerlof, but we're going to actually use this same sort of insight for the market for financing projects. So what we'll find in this lecture is, so if these investors indeed cannot observe the quality, whether the project is good or bad, we'll see that we might have underinvestment, and sometimes we also might have overinvestment, so either possibility can occur. We see that in many cases there will be some cross-subsidization, so where there's too much investment or too much money flowing to bad quality projects and too little money to owners of to entrepreneurs having good quality projects. So actually in an exercise that we'll do in the tutorials, we'll look at an example of IPO underpricing. What we'll also do is we'll figure out that there might be ways in which entrepreneurs can actually try to convince the sellers, well, actually my project is really good. It's not just cheap talk, as people would call this in economics. My project is really good, but so I have to somehow convince the financiers that my project is very good. And in order to do so, I have to take an additional action, and this action is going to be called signaling. So how can we signal? Well, we have to look at an application in which we will signal by posting some collateral, which might in itself be very inefficient, but might serve the goal of proving the point that your project is actually better than some other projects that are available for financing. And we also look at signaling for quality in IPO applications. So the goals in this lecture will be that we will analyze financing projects with this adverse selection, so asymmetric information in the form of actually hidden information. And the workhorse model that we use is a variant basically of what we had before, known as called interval the privately known prospects model. And interval, actually what we're doing will be corresponding to sections in chapter 6. So that's the first bit, and then we'll in particular also analyze costly signaling in this situation. So what is this privately known prospects model that is introduced in chapter 6 in the book? Well, basically the simplest type is there is just two types of projects. So entrepreneurs have good projects. Some of them are good, which are sort of which is reflected in the fact that they have a high probability, which we call P, of success and 1 minus P of failure. And they require an investment, as always, of I. And some other project might be less good or perhaps even bad. They will have a lower probability Q of success, still a positive probability, so there might be success, but it's just a little bit lower. So Q is less than P, essentially. And the probability of failure for a bad project is therefore a bit higher, right? It's 1 minus Q. So with probability 1 minus Q, a bad project results in a payout of 0. Now the quality, so whether it's good or bad, is known to the entrepreneur who's offering this project for financing on the market. But it's not known to the investors, and the investors only know, well, on average, a fraction alpha of projects that are on the market will be good projects, and the remaining 1 minus alpha fraction on the market will be the bad projects with probability of success Q, smaller than P. So that's the setup. So what we're going to do is we're going to analyze these projects. We're going to look at what asymmetric information or hidden information is going to imply about the financing possibilities for these projects. But let's look first at what happens if actually the investors can observe what the project is, whether it's a good project or a bad project. So we call this symmetric information. So we can do this on the slide, but actually we can also do this on paper. So let's just do that and then go back to the slides. So we have these two kinds of projects. One project is good and succeeds with probability P. So 1 minus P is going to fail and requires an upfront investment I. By the way, I didn't say this, but we're going to assume for now, or for this lecture actually, that the entrepreneur has no assets. So you can forget about the A that we had before. And by the way, we'll also see we didn't encounter here any B, right? So the B, the private benefits part that we looked at in the moral hazard case, that plays no role in this lecture. So we just look at this hidden information. It's just given that some projects are good and have this success probability P, whereas, so we call this the good project and the bad project. An entrepreneur might have a bad project. She knows it's bad, and that means it might succeed, but only at probability Q, which is going to be lower than P. So under symmetric information, actually, as a benchmark, the financier will also know whether this project is good or bad. So, well, if you have a good project, you will go to the financier. The financier sees, oh yeah, this is a good project. So I'm willing to finance this project against remuneration such that I'm going to break even, because again, we are going to assume here perfect competition among investors. So you cannot expect to do, as an investor, you cannot expect to do better than breaking even. So that will mean break-even condition is going to be a participation condition, if you wish. Participation for the lender. With the probability P, this project is going to be successful, and there is going to be an outcome R, out of which a fraction, let me call this RG, let me call it RBG just to be clear. A fraction RBG is going to the good entrepreneur, to the entrepreneur owning this project, and the remainder, so R minus RBG, is going to the investors. Whereas if there's failure, so this is a good project, everybody knows this is a good project, with probability 1 minus P, the outcome will be 0. So the participation constraint is, well, if it succeeds, this is the amount that the investors get. They get this with probability P, which is the success probability, and they know this because it's a symmetric information benchmark that we're looking at. So this has to be at least equal to I, and given perfect competition, it will equal I. Same way, if you have a bad project, everybody knows it's a bad project, but that might not matter, because still there might be somebody who's willing to finance this, but they will expect there's going to be this lower probability of success, so Q, so they want their money back, which they will only get with probability Q. So this will be guiding the participation of the investors in bad projects. So what does it imply? Well, you can solve then what's the amount of money that an investor is willing to leave to the entrepreneurs, and the remuneration to the entrepreneur upon success, which is this RB for the good entrepreneur, will be, if you solve this, of course, this will be R minus I over P. And similarly, if you solve this one, a bad project owner, an entrepreneur having a bad project, might still get success if the project is not too bad, actually. of this form. And you see actually, since P is higher than Q, right, the success probability of a good project is higher than the success probability of a bad project. 1 over P is going to be a smaller number, so R minus I over P is going to be bigger than R minus I over Q. So of course, it's sort of intuitive that we can write a contract which is a good entrepreneur can write a contract which has better terms than a bad entrepreneur, because everybody knows the project is either good or bad. So that's a benchmark. So now we turn from this benchmark to hidden information. So now still the entrepreneur knows whether she's good or bad, but the investors do not know this. So would this construction still work? Well, not really, right? So somebody comes to me, I'm an investor, and it tells me I have a good project, so let's strike a contract with this particular RBG, and then you'll break even. I would be very worried as an investor that this project might actually be bad, because a bad project owner would also like to claim having a good project, because that would guarantee her a higher payoff. So as an investor, I wouldn't sort of take the word of the entrepreneur for this being actually a good project. I cannot verify this anyway. So the best thing that I can do is say, well, I don't know what quality your project is. I only know that on average, the quality of your project will be, well, essentially some average of the good and bad quality projects. So what is going to be useful to introduce here is the average success probability. I'm going to call this M for mean actually. So the M will be the average, well, the success probability of the average project from the point of view of the investors. So investors know that a fraction alpha of projects will indeed be good. So with probability alpha, this entrepreneur might actually be telling the truth, and in that case, the success probability would be P. But it might also be bad, and it's a fraction 1 minus alpha of the project. And in that case, I know that the success probability will only be Q. So now I'm actually a risk-neutral investor, so I expect this project to succeed on average. I'm going to invest in many different projects in this market, presumably. So on average, my project will be some mixture of good and bad projects. So on average, any project in my portfolio will succeed with this average probability M. So what am I willing to do? So I want to participate. So the participation constraint with hidden information, which is what we are looking at here. Hidden info is the setting that we're turning to now. How the participation constraint for the lender is, well, on average, this project is going to be successful with this probability M. What am I getting in that case? Well, it will be total amount R, and I'm willing to give this average entrepreneur a pay of RB, which I call RB pool, because I know there is a pool here both of good and bad quality investors. So on average, I want to break even. It means I will lose on some projects, but I will gain on some other projects. So what does this imply for this RB pool? I can of course rewrite this as RB pool B. Same payout that I will provide, we will be willing to contract on with any type of entrepreneur. The good and the bad types will be R minus I over M. So essentially what happens is all the different entrepreneurs, the good ones and the bad ones, will be pulled together from the point of view of investors. They will all get the same contract because investors cannot distinguish the good ones from the bad ones, so there's no point in giving different contracts to different kind of entrepreneurs. So what is this contract? Well, the contract says, well, actually this will be the payoff for you, entrepreneur, if you succeed, R minus I over M, because then on average, I as an investor, I will exactly earn back what I put in. So now we can observe, well, this M, of course, this average success probability, it's somewhere in between P and Q, right? It's the average success probability, so probability between the weighted probability of the high and the low quality projects, good and bad projects. So it's in between P and Q. So that will also tell us that RB pool, this average, or this payout that we guarantee to any entrepreneur, the good ones and the bad ones, is going to be bigger than the payout that we would have had under full information for the bad ones, but it's going to be smaller than the payout that we would have had for the good ones. So what does that mean? Well, actually, in terms of entrepreneur's utility. So an entrepreneur, suppose I'm a good entrepreneur. So what is my payoff? A good borrower, what's my payoff from entering into this contract in which I only get RB pool? Because I cannot really credibly tell my financiers that I am a good entrepreneur. So what will be my payoff from having this contract with this slightly lower RB pool payout upon success? Well, I know I am a good entrepreneur, so I know my project is going to be successful with probability P. When it's successful, I get RB pool. So now using what this average payout will be in equilibrium, so as to make the investors break even on average to these conditions. So this was this RB pool. So if I plug that in, I see it's P times R minus P divided by M times I. Now the point to notice here is that P is bigger than M, right? P is the success probability of the good project. M is the success probability of the average project between good and bad, so it's lower than P. So P divided by M is a bit bigger than 1. That means then that PR minus P over MI is smaller than PR minus I. So if I'm a good entrepreneur, I have a good quality project, the fact that there are also bad quality projects in the market is going to decrease the total utility that I am able to get from having my project financed by outside investors. It's going to decrease my utility to a value, to this value essentially, which is lower than I would get if I could completely credibly tell the investors that my project is actually good. And of course, vice versa. If I'm a bad entrepreneur, so my project is bad rather, I know my project might still succeed, but with a low probability Q. In that case, I also get the same RB pool because investors cannot tell us apart. And of course, this is going to be QR minus Q over MI. And by the same token, this is bigger than QR minus I. So the fact that I, having a bad project, can hide in a way in a forest of good projects is actually going to raise the utility that I get from getting my project financed. So what we see here actually is that good project owners rather, entrepreneurs having a good project, by participating in this market, they are essentially cross-subsidizing the bad project owners because bad project owners gain a little from this pooling phenomenon, whereas the good project owners lose a bit from participating in this market. Now, this works only insofar as we can actually find an RB pool which satisfies this participation constraint. In particular, what we need is that on average projects need to be, so it's going to work only if M times R, the total average payout of all projects, is bigger than I. If the average project makes a loss, then we can never find a positive RB pool, which actually is going to bring in these investors to finance the average project. So if MR is smaller than I, there will be no financing at all. So even the good projects, which might be positive NPV, which you'll assume to be positive NPV, they cannot get finance in this market because of the presence of these bad quality projects. On the other hand, if so, no financing. All projects go without financing, so cannot be done. So this means underinvestment, right? So this can only happen if the bad projects are really negative NPV, but still the good projects will be positive NPV. Only on average there will be negative NPV. In this case we have no financing. If on the other hand we have indeed this other condition, MR is bigger than I, we will have financing of all projects. And actually we will have financing on all projects. We have financing even if bad projects are negative NPV. So all projects will be financed, including the bad ones, because we cannot distinguish those two as investors, which means essentially overinvestment, because these negative NPV projects should not, in a full information setting, would not be financed. But because they can pool with better projects, with high quality projects, also the bad quality negative NPV projects get carried out here in this case. So we have overinvestment. If MR is bigger than I and also QR is bigger than I, well then both projects merit investment, right? They're both positive NPV, just that the good projects are even more positive NPV than bad projects. Well, then it's efficient that all these projects that get carried out, get financed. So we have efficiency in the sense that all projects that are positive NPV are indeed financed, but we still retain this cross-subsidization where the good borrowers, the good entrepreneurs get slightly less than the total NPV of their projects, whereas the bad entrepreneurs get slightly more than the NPV that their project accounts for. So let's come back to the slides to see this again. So on the symmetric information, we have that the RBG and the RBB are precisely right to make sure that the investors are breaking even on each project individually. So these are the same equations that we just did on paper. So to make sure that, as I mentioned, if you have a good project, if you're an owner of a good project, an entrepreneur with a good project, you will get a contract with a higher payoff for yourself upon success than if you have a bad project. But if the type of the entrepreneur, so the quality of the project, is not observable, well, then everybody will obviously have an incentive to claim, well, my project is actually good, but investors have no reason to believe these claims, and they will regard each project basically as interchangeable, the good ones and the bad ones. So they might still be willing to participate in the sense of finance these projects. It's going to depend on the average success probability, which are called M. But all projects will be financed with the same kind of project, which is going to be RB. I call it the RB pool in my on the paper. So you could compute what this RB is. And what we found was, well, if this M times R is actually lower than the investment cost, MR is smaller than I, no project will be financed. The market breaks down. So there's underinvestment. So when will that happen? Well, if the bad project type, bad quality project is negative NPV, so not creditworthy, and is also sufficiently present in the market to basically wash out all the positive contributions from the good quality projects which are positive NPV. So if this total average NPV of project is negative, then no project will be financed, so underinvestment. If on the other hand we had this MR bigger than I, so the average project is creditworthy, then we always have this cross-subsidization, and we might actually have overinvestment because this might still occur even though the bad quality projects might still be negative NPV. So this is a summary. Basically, I'm not going to say this once more, but you can read this. Is what I just said twice already. So this ends the first part. And we notice from this first part, well, if you have a really good project, you're actually not so well off from having to pool with these bad quality projects, and you might want to do something about this. And what can you do about this? Well, we'll turn to this next. We're going to look at separating contracts. Is there some way in which I can credibly convince the outside investors that my project is really good? So we're going to have a look at signaling by good project owners in order to signal that indeed their projects are good and they are not just posing as good investors while in reality being bad